This is the first lesson in chapter 3, 3-1, relations and functions. So let's talk about what those two things are. Well, let's start with relations. Relations are sets of ordered pairs. So instead of giving you like different points in parentheses, they put them together in a table. So you have your x and your y coordinates together. It could be like this, or it could be like this, where 3, 1 is a point, negative 1, 3 is a point. Or it could be like this, where it's 2, 0 is a point, 3, 1 is a point. Now the x's are called inputs because usually you plug in your x in an equation, and then when you solve it, you get your output, which is the y. So the x goes first and then the y goes second. Now, what makes a relation different from a function? Well, with a function, every x has only one y pair. That means that the numbers for x can only give you one answer for the y. They can't give you two different numbers. Okay, so let's start with the first question, example number 1, which is domain and range. So domain and range is, domains are the x values and range are the y values. So for letter A right here, the domain for this relation would be 2, 3, 4, 5, and 6. That would be my domain. The range would be the y values. So 0, 1, 2, 3, and 4, and that's domain and range. For letter B, these are my x's. So you like to list them in order from least to greatest. Those are my domains. Those are my x's right here. But then for range, range is not in order. But when I write it down, it should be. So the smallest number is actually negative 2. So let me move this up. I would put negative 2 first. Then the next number is the 1. So I'll put a 1 next. Then 3. And then 6. And there's my range. Now if you notice, I didn't write negative 2 twice. I only wrote it down once. This number shows up twice, but you don't have to write it down twice. That number you only have to write down once in your list of the range. Okay? All right. So that is domain and range. X's and Y's. Pretty straightforward. Next. So for number 2, we are analyzing situations. So analyze each situation, identify a reasonable domain and range for each situation. So what does that mean? So if you're analyzing this, what they're basically saying is, sorry about that, it's kind of blurry. What would make sense in this scenario? So for letter A, right? For letter A, if you're going to go bowling, well, if you don't go bowling, you're not going to pay anything, right? That's $0. But if you go bowling once, you're going to pay $2.75. If you go bowling twice, you have to pay for 2 games. That would be $5.50. And if you play for 3 games, it would just keep getting more expensive, $2.75 per game. So when it talks about a reasonable domain and range, your domain is any number greater than 0. 0, 1, 2, 3 for domain. For range, though, for range, your numbers would be increasing from 0 by $2.75. So if I add $2.75 to this, it would actually get $8.25. So where x is this part, that's my domain, and range is this. Okay. Now for situation B, let's see, a car travels 25 miles using 1 gallon of gas. Okay, well this is kind of straightforward. If you have no gas, you're going 0 miles. Now if you have 1 gallon, you're going 25 miles. If you have 2 gallons, you're going to go 50 miles. If you have 3 gallons, you're going to go 75, and etc., etc., etc. So the reasonable domain would be from 0 going up, and then for range, numbers from 0 but increasing by 25. Okay, now the next part of this is what do they look like if you graph it? So I'm going to graph these numbers. Okay, so let me move this up here. Let me get rid of this. So if I'm going to graph this situation, I'm only dealing with positives. So that's the first important thing to notice. In these scenarios, you don't have to worry about the negatives because it wouldn't make sense in the real world. There would be no negative bowling games. You couldn't go negative miles because there is no negative gas. So you're only working in quadrant number 1, all right? Okay, so here, since these are my x's, I would just label 1, 2, and 3. Now, at 0, it's 0. At 1, 275. So I'm going to count this a little differently. Let's count it by going up to 8. Let me count it by 2, 4, 6, 8. Let me count it like this. So then in between is 1, 3, 5, and 7. Okay? All right, so if you're going to go bowl 0 games, you're going to pay $0. If I'm going to go bowl 1 game, I'm going to pay $2.75, which will be somewhere around here. If I'm going to go bowl 2 games, that'd be $5.50. That'd be somewhere around here. And then if I'm going to go bowl 3 games, $8.25, which would be somewhere around here. Okay, now, I am not going to connect these because I cannot buy 1.5 games. If I'm going to go bowl, they're going to charge me for playing 1 game. And if I'm done with that game, if I say, can I play some more? They're going to charge me for another game. I can't pay for half a game. So guys, this is what we call discrete. Discrete graphs have points that don't connect because it wouldn't make sense. You couldn't have a half game. All right. Here, if you're going to drive 0 miles, you need 0 gas. But if you have 1 gallon of gas, 2 gallons of gas, 3 gallons of gas, how far can you go? Well, let's count this one by 25. 25, 50, 75, 100. Okay. So if I have 1 gallon, I can go 25 miles. If I have 2 gallons, I can go 50 miles. If I have 3 gallons, I can go 75 miles. Now, can I connect these dots? Can I put in a half gallon of gas? I can, and I've done it. Can you put in 1.5 gallons of gas? Yeah. Even though you don't have the prices, you can still do it. You can still put 2.5 or 2.25 prices. So because you can actually put numbers in between 0, 1, and 2, you're not limited to these numbers. You connect that line. So like if I want to go put 3.5 gallons of gas, 3.5 would be somewhere right here. That's a point. I can do that. I can put 3.5 here, 2.2, 1.7. So this is what we call continuous. Continuous. So if you can connect the dots because it makes sense in this situation, you would call it continuous. All right, that's example number 2. All right, example number 3. Functions are 101. So this is a map function. So it kind of shows you what they're connected to. So if I wrote down these points, right? If I wrote down -2, 5, that's 1 point. 3, 6, that's another point. 3, 7, that's another point. And 4, 8, that's another point. So that's what these arrows are telling you, that this X is connected to that Y. Now when you look at this, you notice that the X's, there's 2 X's that are the same. Okay? What should happen is when it says 1 to 1, that means that the 3 should only be connected to one number. So it should only be connected to 1 Y. It should not be connected to 2. This is not 1 to 1. Think of it like this. Your X is cheating. X is cheating on 6 and on 7. So because of the X, this is not a function. Your X has to be loyal. Okay? And you're always looking at X. The Y's really don't matter too much. It's that your X's are being loyal. That your X's have a 1-to-1 relationship. Okay, in a line, if I wrote down these points, right? So let's just say this point. That would be 0, 3. That would be 1, 2. This would be 2, 1. It doesn't matter that I see repeating numbers on the other side. No, 0 is connected to 3, 1 is connected to 2, 2 is connected to 1, here 3 is connected to 0. Okay, each x has only one pair. So this is a function. And that's the difference. All right. Number 4, constraints. So let's talk about constraints. Well, for this, we should read the scenario. Margaret has a monthly budget of $50. So $50 budget. I'll write that down. 50 budget. So if you don't know what a budget is, it's the limit. It's how you limit your spending. Okay. She maps the amount of money she spends each month to the number of items of clothing she buys. What constraints are on the domain? Okay. So she maps the money to what she buys each month. So then the other number is how much she bought. What did she bought or buy? Autumn's what she bought with that money. Okay. So this is going to be a little strange to try to explain. So let me try to map it out for you. Let's say in 1 month she spends $0. If she spends $0, she can't buy anything, right? So that point would be 0, 0. And let's just say 1 month she spends all her money. She spends $50, and with those $50 she buys 5 things. So 10, 20, 30, 40, 50. So $50 buys her 1, 2, 3, 4, 5 things. So that point would be 50 and 5. All right. Now, this line would be somewhere in between here, right? But actually, I take that back. I take that back. The reason this would be wrong is, could she buy 1.5 items? If she goes shopping, could she say, you know what, I want to buy half a shoe? No, it wouldn't make sense. It wouldn't make sense to make it like this. So actually, it shouldn't be continuous. This is wrong. It would be more discrete. So like, she can buy 1 item with $10. And maybe she could buy 2 items with $20. So it would be points. It would be like this. And you wouldn't connect them. The graph would look something like this. And then here's the thing, you would stop at 50. So you couldn't go past 50. So your constraints would be from $0 to $50. You couldn't put any number greater than 50, and you couldn't use any number less than 50. So one way you're going to see this written in the future will be like this. Your x's are in between 0 and 50. Okay? For your domain. That's your limit from 0 to 50. And that's it.